So please give a warm welcome and standing ovation for Matthew Hart.
Hi, so welcome to my talk about making Umbraco deployment swift. I had a bunch of ideas of how I would deliver this talk. Do I make it subtle or glaringly obvious? I decided rather than dance around the subject, taking one step forward, 3 steps back, let's make it obvious. Welcome to my talk. Matt's version. Full disclosure, I have never listened to Taylor Swift, or not noticed I have. This is an office joke that has just gotten out of hand. I started with ChatGPT for title inspiration and really set my eyes on this title, posted it to the Crumpled Dog Slack channel, and Mark chimed in. I then proceeded to make a thread and corrected the spelling. And then my director corrected my mistake, and the song titles started flooding in. Yes, I really don't know much about Taylor. I know her songs. As far as I know, there aren't any more Taylor Swift references anywhere in the talk. Right, let's get started with some DevOps. Right, I'm not sure how that got there, honestly. No more references. So when planning out your approaches for deployments, the less human interaction, the better. Remember the days of publishing from Visual Studio to a target? Cool to be aware of and how the mechanisms work, but it can be subject to human error. Consider investing in an automated pipeline runner such as GitHub Actions to carry out your deployments. Strive to get your runner to do almost everything needed for a deployment: build, package, test, and deploy, and then test again. Additionally, gradually move away from using the Azure portal and learning infrastructure as code languages such as Terraform or Bicep. Master the Azure CLI for your infrastructure changes, especially long, tedious tasks, such as, so here's a repo that I have called Azure CLI Quick Wins. This repo just has a few small examples of using the Azure CLI to achieve a few things that might be quite tedious to do in Azure, such as if you have a web app that uses Cloudflare and you want to keep that web app private, Cloudflare provides a URL with all the IP addresses that they will communicate on. And so I've got a small PowerShell script in this repo that will grab all those IPs from that endpoint and then loop through them all and assign it to your web app firewall. There's also the case where you might have a web app that might have like 20 domains. This usually can happen if you have a client that might have like their single domain, but then their subdomain is all the different languages like DE, SW, etc. And so if you put all those items into like a text file with new lines, I have a script that will go through each line and then add it to the web app, so feel free to check that out. Azure is full of settings that can overwhelm you. With infrastructure as code, you define your ideal arrangement of settings and can reuse it over and over. Pair your runner with your chosen infrastructure as code approach, and you can then PR and code review your infrastructure, allowing you more chances to spot those pesky configuration errors that you might do, or when doing that migration or releasing an upgrade. So let's talk about GitHub Actions. It's extremely flexible and can be heavily customized to how your business works. To achieve concurrent choreography, I recommend working out what tasks are involved when building your website, such as maybe you're determining a version number for your work, building the front end, building the back end, deploying to 2 targets if you've got load balancing, so you've got the Umbraco and the front end, and maybe running unit tests or accessibility tests. Ideally, those could be run on a separate job. Work out what tasks can run together and separately. Does your build require Windows? What parts of your build could be moved to a cheaper Linux agent? We have a website at Crumpled that has a lot of unit tests, but certain tests won't work in Linux, so GitHub gives you the option to spin up Windows agents if needed, making the best of both worlds. It's also worth knowing that with GitHub, it lets you run many concurrent jobs compared to Azure DevOps. So in Azure DevOps, you might specify how many Microsoft-hosted runners that you want to use, but in GitHub Actions, for example, we're on the team plan. We can run 60 concurrent jobs throughout our organization, whereas DevOps, you might be limited to 2 if you just pay for 2. And if you're on enterprise, you can run 500 concurrent jobs, which is crazy. In the screenshot, the front-end build and the back-end build are separated. Why? I'm aiming to save on real-world time. Notice that the total duration of the whole build was 5 minutes and 55 seconds, but the billable time is 11 minutes. The same goes for the final deployment task. They both are initiated in parallel to speed up commit to site. Just a quick drink. This results in your Umbraco site being deployed to a target much faster than running tasks in sequence, like so. So here's a little bit more detail on the build I showed previously. Again, the goal is to reduce real-world time of running the build and on deploying the website rather than billable time. Both jobs are triggered at the same time, and since the backend build is dependent on the compiled front end, we have to wait for the front-end task to finish before we can continue. So the section highlighted, we will wait for the front-end build to finish before continuing. So typically there's no wait with a front-end build because it will usually typically finish before the .NET build is done. So in this case here, we download our compiled front-end artifact from the other job, and then overwrite the www root folder that was produced from .NET Publish. This approach works great for us at Crumple due to having a standard approach to building your front end. Ensure you strive to stick into a standard for your code bases that was repeated throughout your organization. If you saw Lottie's talk yesterday, she discussed .NET templates. You could bake your own GitHub YAML into your .NET template, and this enables your DevOps engineer to have an approach that is always ready for it. Azure Web Apps have a powerful feature known as slots. It's really handy to verify a deployment before you make it production-facing when you swap. I like to use slots when I'm in the final phase of an Umbraco upgrade. Duplicate the production database, have the slot use the production database, and the production use the copy. Run the upgrade on the slot, and then swap them and delete the copy if we can write on. You can also do something we like to call the slot dance. This involves adjusting the weights of the slots in the Azure portal. So basically, we had an Umbraco 12 site that had about 50,000 items in the index and a lot of media. And the problem we were seeing is when we would deploy it to the slot and then swap it to make it production-facing, is that the indexes would show as 0, even though on the slot it would say 50K. And what we found is if we do the slot dance instead, where we just adjust the weights, then we can technically make our new release production-facing, but not do a swap, and so the indexes remained intact. And then we could deploy to the production slot and then readjust the weights back. Pair this sort of approach with the Azure CLI, GitHub Actions, along with reliable testing, and this can all be managed for you by GitHub Actions. So writing Bash is very powerful to use Bash for Linux agents. It has very powerful utilities such as grep, sed, curl. However, it's really hard to learn and master. This is where our hidden love story with ChatGPT and Bash comes in. AI has come a long way since I sort of played with this last year. There are probably more amazing prompts that you can do in ChatGPT 4.0. However, let me show you some examples of how I use ChatGPT and Bash together. So I was asked how could we pull out the csproj name from the .umbraco file that you get with a cloud project. I knew that grep, a utility in Linux, could probably do this. So I got ChatGPT to have a look at this, and it suggested the following. I thought, okay, let's sort of take this approach, and opened up WSL, which is a Linux terminal that you can use in Windows, and ran the command against that .umbraco file. It correctly pulled out the csproj name regardless of what Umbraco file I threw at it. Another example I wanted to do was some string manipulation with Bash. I wanted to convert a branch name into a format to name a resource group in Azure. This time, ChatGPT suggested using sed. I really don't know much about sed, but I know it's a very powerful tool. Same situation, ran it through WSL, and again, it worked nicely. A nice small solution to generate a name using a naming convention that we have defined. The idea being, if I wanted to create a new environment with infrastructure as code, a developer could create their branch, so they have like maybe iteration and the name of their iteration, and then this piece of Bash would then be able to extrapolate the name of the work we're doing, and then create a resource group with that name. And then if you wanted to deploy all your resources for Azure, it'll be in that resource group. And then as a DevOps engineer, I can then see all of the resource groups in our Azure portal and know what each resource group is for. And so if, for example, it didn't remove all the resources, I can then check with my colleagues, oh, why is this resource still here? Are we still using it? And can delete the whole resource group. So these examples were ran in late 2023, and again, ChatGPT 4.0 is probably a lot more capable now. And lastly, in this example, I was struggling to get Carl to post to a service we use called Ghost Inspector. Ghost Inspector is a service that provides customized automated browser tests for our websites. The objective was to have a status appear on our open PRs to warn developers of front-end issues from their changes. To do that, I needed to provide the commit ID with the post request, but was bashing my head against the wall with the syntax errors I was getting. So queuing ChatGPT to figure out all the JSON escapes I needed in the request payload. Same result, ran it in WSL and was able to send my request. And so success after adding the call command to my GitHub action, the test result now shows on the PR, and I can restrict a PR if the test doesn't pass. The test is triggered after the deployment is complete. This way we have our changes on a URL to run our tests against. Ghost Inspector is linked with our GitHub organization and just needs the commit hash to put the status in the right place. Did you know you can also write your own tasks? Just like a reusable function, here we define an approach to deploy to Umbraco Cloud. And we can reuse this approach for all of our cloud sites we have that use CI/CD. So all I need to do in the YAML is reference the two tasks from our repo where we have our action, and then that will handle our deployment to cloud. So first we sort of test that we can build it, and test we can build the back end and front end, and then we have our custom action to create the source for Umbraco Cloud, and then the next task to deploy the actual publish to cloud. From what I've seen, you can use Bash, PowerShell, or JavaScript to write an action. This is a great way to sort of contribute back to the community if, like me, C# isn't your strength. Where am I? Oh, and that's also the QR code and where you can get the action right now if you want to try it out with your own cloud project that you have with CI/CD. So if you're still not persuaded by using your own task or using someone else's, here's the same action that I showed previously that you can get from our GitHub. We needed to handle mismatches between our repo and Umbraco's. So when the task runs the deployment to cloud, a mismatch can happen due to an automated upgrade that cloud will perform. Umbraco will provide a git patch file when a mismatch happens, and we can generate an automated PR with the changes. We also create the branch name based off the deployment ID that cloud will give us back. It's then just a case of reviewing the PR and merging it to get our repo in sync with Umbraco. Again, this is reusable and should work. I don't know where my mouse is gone. Oh, whoops. Where am I gone? Yeah, I'm back. I can't find my mouse. Anyway, this is so I just wanted to sort of talk about flexible environments. So ideally, it would be really nice with this action and flexible environments that if you were to create a branch with your work, that we could communicate with Umbraco Cloud using the single action and say to Umbraco, oh, I want an environment named this project. So we've got iteration, maybe / the name of the iteration you're working on for the client. And then that will go to cloud and say, oh, I would like this flexible environment called this iteration. And they'll create the environment and deploy to it so you can test your new iteration. And then when we delete the branch, or merge it and then delete it, we can then tell cloud, oh, we don't need the flexible environment anymore. Please get rid of it. And that'll be really good to sort of incorporate into this action. So I saw the flexible environment thing. I thought I'd just add that in quickly. So this was a happy accident. Umbraco Cloud will generate a UDA file if someone changes the property on the cloud site directly. That UDA file ends up in Umbraco's repo, and we can retrieve that UDA file via the git patch file and recreate the PR using the same mechanism that we used before, keeping our repos in sync. Again, no additional YAML was required, and it's using the same GitHub action tasks that we've made. If we want to add more functionality to the action in the future, we simply create, update our action and create a new tag on our repo, and then you can update your YAML pointing to that tag. So coming back to running tasks concurrently, maybe you're wondering how I was getting GitHub to wait for another task to finish. GitHub doesn't natively support the idea of waiting for other jobs, so I stumbled upon this repo for this action called wait for jobs. Just like our Umbraco Cloud task, I referenced this task in our pipeline YAML, and all it needs is the name of the job that it needs to wait for, and it will just wait for it. Out of the box, this pipeline can now wait for the front-end build to finish before continuing on with the rest of the .NET build. Again, in most cases, the front-end build will just finish before the .NET run, so typically there's no wait. This is just a precaution that I've added in. So here are some potential GitHub action ideas off the top of my head that could be valuable to the community. So usync has a CLI. Being able to trigger an import and get the report of that import to a PR, or rebuilding the cache after a deployment has occurred, will be via the GitHub runner will be very valuable. If we had the ability to simplify the spin up of environments using infrastructure as code, we could have a GitHub runner that uses a usync CLI task that could create the database, create the web app, and then trigger usync CLI via this action to then update that site with all the content that the other environments have. And this could be an action that everybody could sort of use and share and collaborate with to have a defined approach. IIS deploy, there isn't much going on with IIS-based deployments on GitHub Actions at the moment. Ideally, I want Microsoft to create their own action. They have stuff for Azure Web Apps. They have their own sort of maintained action, but not for IIS, which is quite strange. So, but I'm currently working on exploring how I could make my own action for IIS and looking at things called canary deployments, where you might have like an IIS site called A and an IIS site called B, and being able to deploy to one, point the traffic at that one, and then deploy to the other one and point the traffic at that one if you want to have like seamless deployments to IIS. It would be really nice if a health check, the Umbraco health check, had a GitHub action. Be useful to be warned if your Umbraco website is misconfigured or behaving has an unhealthy state when you're doing your deployment, and that show up in the PR as a status that the Umbraco health check's failing. And there's also the our Umbraco health checks from Paul Seal. I think that you could add that to your site and then have customized tests for your PR that Umbraco would run on the environment. And any other pretty words you may be thinking of right now? Right, just one drink. So GitHub has a blog, and they have a section for actions. A big post for me was that they announced v4 artifacts. Artifacts are tasks that upload and download your build output to GitHub storage for other runners to consume. v4 has significant performance boost compared to v3. So as a result, a 47-second upload task is reduced to 7 seconds. Now think about how many times you may need to upload and download artifacts for your deployments every month. That 40-second reduction ends up saving you potential hours of billing per month, depending on how many deployments you do per month. Not to mention that this example was a very small project. v3 performance was horrible. A bigger project would have performed a lot worse. v4 is consistently fast, regardless of project, in some cases taking less than a second to upload and download an artifact. Make sure to keep an eye on the versions of your actions and try out newer versions. In VS Code, holding Control and clicking your action name in the YAML will open the browser and take you to the Actions repo, where you can check if there's any new releases and update your tag. So at the end of that bit, you see at v4, that's the tag. So they have a tag called v4 in their repo to the commit. That is the latest version. So maybe they'll have v5 for the next commit, which is their next release. And you can just update the tag with v5 to get to the new one. Since working on this talk, GitHub has released more interesting articles. ARM64 looks promising. Can we build Umbraco on an ARM CPU? Potentially a low-power, sustainable approach for your deployments. Verifying artifacts. Do you have the need to sign your artifacts with the commit they came from so you can trace back where this artifact came from in your code base? Bringing enterprise-level security. Attaching your runners directly to a private Azure VNet allows you to deploy to lockdown environments without needing an agent with a fixed IP address. You can just use GitHub's standard runners, and it will connect to the VNet and deploy to that lockdown environment without needing that IP restriction. Keep an eye on the blog to stay swift. Speaking more on staying swifter, let's compare the performance of GitHub Windows runner versus a Linux runner. The runners are building the same code base, one of our clients on Umbraco 13 website, and the YAML in both agents is almost identical. However, in the commands to create the zip are different. So Windows is using PowerShell to create the zip, and Ubuntu is using the native zip command that it has. Here's the result of the test. Ubuntu takes half the time nearly to complete the build compared to Windows. Here's a breakdown of the different tasks in the build. For some reason, Windows takes nearly 2 minutes longer to grab our cached NuGet packages. These packages are cached in GitHub, so it's a little puzzling why Windows is taking 2 minutes and 8 seconds, and then Ubuntu is just taking 29 seconds. Setting up the agent with .NET 8, because it's Umbraco 13, takes 29 seconds more on Windows. Other than that, the rest of the tasks are almost nearly the same in time it takes. It's also worth knowing that Windows agents cost more build minutes than Ubuntu. Therefore, I highly recommend you stick with Ubuntu agents where possible. Remember, you can see that the upload artifact task is super quick on both agents because it's using v4, almost taking, sorry, it's gone down here, 5 seconds to deploy our artifact, and would have been a lot worse in v3. So I had to try ARM runners next. Please note I ran this test over the weekend and have not explored ARM fully. The runners are building the same code base that I showed before, and the YAML was the same. Here's the result. So Ubuntu takes 11 seconds longer than the regular agent that we had before, but while Windows couldn't even check out the repo. However, this Ubuntu agent is using only half the CPU of the standard agent that I used before. So it's using 2 cores instead of 4. So it's not bad for an additional 11 seconds and using half the power almost. Great for a more sustainable build and deployment. However, be aware that ARM is under a different billing and does not come out of your standard build minutes. This also revealed to me that GitHub lets you have custom agents. So if you needed a 64-core Windows or Ubuntu agent, you can get it. So in summary, while running your jobs concurrently may not appear to be sustainable since you're consuming more minutes, it does enable your developers to get feedback from tests faster, roll out work faster, and close the laptop faster. I could be more sustainable by removing the wait for jobs task and looking into triggering the action when the artifact is made for that front end. However, that's only really necessary if your front-end build takes a long time to compile compared to the back end. Speeding up your front-end build process is the ideal solution for that scenario. Staying swift is also important to be sustainable. GitHub is constantly changing and improving, updating your actions. Maybe when ARMs are more supported, using ARM CPU agents are easy ways to reduce your carbon footprint. Sticking with Ubuntu agents and using Windows as little as possible can also reduce your footprint and bills. Thank you. I hope I inspired you to tinker with your YAML and create your own GitHub Actions tasks. Here's some quotes that I liked. Any questions? And to save your question, so far my favorite Taylor Swift song is Cruel Summer.